question of whether a green grounding wire is needed when installing electrical metallic tubing, commonly known as EMT, with metal boxes can be addressed directly. The answer is no. However, there are nuances to consider for ensuring a safe and code-compliant electrical installation. EMT itself, when properly installed, can serve as an equipment grounding conductor. This means it can provide a path for fault current to return to the source, tripping a breaker and preventing electrical shock hazards. The effectiveness of EMT as a grounding conductor depends on several factors. Firstly, the EMT must be installed with approved fittings. These fittings are designed to maintain a secure and electrically continuous connection between the conduit sections and the metal boxes. The fittings should be listed for grounding purposes, meaning they have been tested and certified to meet specific standards for electrical conductivity and mechanical strength. Secondly, the connections between the EMT and the metal boxes must be tight and free of corrosion. Loose connections or corrosion can increase the impedance of the grounding path, reducing its effectiveness. It is important to clean the contact surfaces of the conduit and fittings before assembly to remove any dirt, grease, or oxidation. Applying an antioxidant compound can further enhance the connection and prevent future corrosion. Thirdly, the metal boxes themselves must be properly grounded. This is typically achieved by bonding the box to the EMT system. The National Electrical Code, or NEC, provides specific guidelines for grounding metal boxes. Generally, a bonding jumper wire is used to connect the grounding terminal inside the box to the box itself. This ensures that the box is at the same electrical potential as the EMT system. The size of the bonding jumper wire is determined by the size of the circuit conductors. NEC Table 250.102 current and NEC Section 250.122 provide guidance on selecting the appropriate size of the grounding and bonding conductors. While EMT can serve as the equipment grounding conductor, there are situations where a supplemental grounding wire is required. One such situation is when the EMT system is used to ground sensitive electronic equipment. Electronic equipment can be susceptible to electrical noise and interference, which can be minimized by providing a dedicated grounding path. A supplemental grounding wire can provide a lower impedance path for high-frequency noise, improving the performance and reliability of the equipment. Another situation where a supplemental grounding wire may be required is when the EMT system is subject to mechanical damage or corrosion. If the integrity of the EMT system is compromised, the grounding path may be impaired. A supplemental grounding wire can provide a redundant grounding path, ensuring continued protection against electrical shock hazards. When a supplemental grounding wire is used, it must be sized in accordance with the NEC and connected to the equipment grounding terminal inside the metal box. The grounding wire should be run along with the circuit conductors inside the EMT. The grounding wire should also be connected to a grounding electrode system such as a ground rod or a water pipe. The grounding electrode system provides a connection to the earth, which helps to stabilize the electrical potential of the system and provide a path for fault current to flow to ground. In addition to the above considerations, it is important to follow all applicable electrical codes and regulations when installing EMT and grounding systems. The NEC is the primary source of information for electrical installations in the United States. The NEC is updated every 3 years, so it is important to use the latest edition. Local codes and regulations may also apply, so it is important to check with the local electrical inspector before starting any electrical work. Proper grounding is essential for electrical safety. A properly grounded electrical system can protect people from electrical shock hazards and prevent damage to equipment. It is important to understand the principles of grounding and to follow all applicable codes and regulations when installing electrical systems. Here is a more detailed breakdown of key concepts. Firstly, equipment grounding conductors provide a low impedance path for fault current to return to the source. This path allows the fault current to quickly trip a circuit breaker or fuse, interrupting the flow of electricity and preventing electrical shock hazards. Secondly, bonding is the process of connecting all metal parts of an electrical system together to create a common electrical potential. This includes metal boxes, conduit, enclosures, and equipment frames. Bonding helps to minimize voltage differences between metal parts, reducing the risk of electrical shock. Thirdly, grounding electrodes provide a connection to the earth. This connection helps to stabilize the electrical potential of the electrical system and provide a path for fault current to flow to ground. Common grounding electrodes include ground rods, water pipes, and metal building frames. NEC Section 250 covers the requirements for grounding and bonding. This section provides detailed information on the types of grounding electrodes that are permitted, the size of grounding and bonding conductors, and the methods for connecting grounding and bonding conductors. NEC Article 358 covers the requirements for electrical metallic tubing. This article provides information on the types of EMT that are permitted, the methods for installing EMT, and the requirements for supporting EMT. When installing EMT, it is important to use the correct fittings. Fittings must be listed for use with EMT and must be properly installed to ensure a secure and electrically continuous connection. Compression fittings are generally preferred over set screw fittings as they provide a more reliable connection. When cutting EMT, it is important to ream the cut ends to remove any burrs or sharp edges. Burrs and sharp edges can damage the insulation on the conductors and create a potential for electrical shorts. When bending EMT, it is important to use a conduit bender that is designed for use with EMT. Using the wrong type of bender can damage the conduit and make it difficult to install. When supporting EMT, it is important to use the correct type of supports. Supports must be spaced in accordance with the NEC and must be securely fastened to the building structure. In addition to the above considerations, it is important to follow all applicable safety precautions when working with electricity. Always disconnect power before working on any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Use insulated tools. If you are not comfortable working with electricity, hire a qualified electrician. Here are some additional points to consider when deciding whether to run a supplemental grounding wire. Firstly, the type of equipment being grounded. Sensitive electronic equipment may require a dedicated grounding path to minimize electrical noise and interference. Secondly, the environment in which the EMT is installed. EMT that is exposed to corrosive environments may require a supplemental grounding wire to ensure continued protection against electrical shock hazards. Thirdly, the local codes and regulations. Some jurisdictions may require a supplemental grounding wire in all EMT installations. The decision of whether or not to run a supplemental grounding wire should be based on a careful assessment of the specific circumstances of the installation. If you are unsure whether or not a supplemental grounding wire is required, consult with a qualified electrician. The NEC provides specific requirements for the size and type of grounding conductors. The size of the grounding conductor is determined by the size of the circuit conductors. NEC Table 250.122 provides guidance on selecting the appropriate size of the grounding conductor. The type of grounding conductor must be suitable for the environment in which it is installed. Grounding conductors must be protected from physical damage and corrosion. Grounding conductors must be securely connected to the equipment grounding terminal inside the metal box into a grounding electrode system. A grounding electrode system provides a connection to the earth, which helps to stabilize the electrical potential of the system and provide a path for fault current to flow to ground. Common grounding electrodes include ground rods, water pipes, and metal building frames. The NEC provides specific requirements for the installation of grounding electrodes. Ground rods must be driven into the ground to a depth of at least 8 feet. Water pipes must be used as grounding electrodes only if they are in direct contact with the earth for at least 10 feet. Metal building frames must be used as grounding electrodes only if they are effectively grounded. In addition to the above considerations, it is important to follow all applicable safety precautions when working with electricity. Always disconnect power before working on any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Use insulated tools. If you are not comfortable working with electricity, hire a qualified electrician. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before starting any electrical work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock hazards. Always follow the NEC and all applicable local codes and regulations.